nearest neighbor classifier. In this lecture, I will go through K nearest neighbor classifier and multi-class classification. K nearest neighbor classifier, or in this classification, we'll go through a simple example. For example, here all documents, all red circles represents document with label government. All blue circles represents the label science, and similarly all the documents represented by black circles represents the arts type of document. And nearest neighbor classifier shows the count of, depends upon the count of nearest neighbor. For example, in this case we use the K nearest neighbor with K is equal to 6. Now we have a document and we don't know whether it is related to the science class, arts class or government class. So in this boundary we will check the 6th nearest neighbor of the document represented as yellow rectangle. So these are the inside the boundary. There are 6 points which shows the nearest similarity, 6 nearest similar documents with respect to documents represented by yellow rectangle. Here the count of documents represented as a red circle are in majority. So we will decide that documents represented as yellow circle will belong to the government class. So this is the general trend or technique for K nearest neighbor classification. Here the classification depends upon the nature of the nearest neighbor, but to identify the similarity or to calculate the similarity, we will use either similarity distance measure techniques like Manhattan distance, Euclidean distance, etc., or cosine similarity measures. And finally we can estimate the probabilistic similarity. Now this is a simple approach for K nearest neighbor approach to classify a document D into the class C. First define the K, how many nearest neighbor we want to use to classify the given document D. And next step is a count of number of documents I in N which belongs to C. Now next we estimate how many documents which are related to class C and present in that neighborhood count. Here PC by D for red documents will be total 6 documents are there, and out of 6 documents total 5 are there for red documents. So for red class P C by D is equal to 5 by 6 as generally I by K. So I is equal to 5 and K is equal to 6. So 5 by 6. And for blue documents it is 1 by 6. So basically 5 by 6 is greater than 1 by 6. So yellow document will be the part of government document. Now choose the class for argument as I already discussed. Now some important point of K nearest neighbor algorithm. The definition of KNN. Consider the two class problem. Let K be an odd number denoted by X and I, the ith nearest neighbor of X. In a training size of n documents, similarly yn be the ith nearest neighbor of y in the training size of n. Now according to the K nearest neighbor rule, we will decide that document will not be the part of yn to the I if number of k nearest neighbor will be less than k by 2, less than or equal to k by 2, where number of documents which belongs to the class y by 2, number of documents, suppose number of y represents the yellow documents, number of yellow documents which are the nearest neighbor of the given document is less than k by 2, where k is equal to k nearest neighbors, k may be 4, k may be 3, 5, 7, etc. For example, we take 7 nearest neighbor algorithm. K is equal to, then if the number of documents in nearest neighbor is less than 7 by 2, then we will decide that that document is not related to the class of yn. Similarly, if it is greater than 7 by 2, then we will decide that it is a part of that class. Here odd number is taken just to avoid the case of similarity. For example, in case of odd 4 by 2 is equal to 2, then there may be two similar cases, then it creates the decision problem. It may create the decision problem. To avoid such kind of decision problem, we generally consider the odd numbers with k nearest neighbor classifiers. So k we generally take as odd number. Hence the k nearest neighbor rule finds the k nearest neighbor of x and uses the majority vote of their labels to assign the label to x. Now the training and test cases of k nearest neighbor. Training: just pre-process the documents, selects the k and identify the classes, and then return the document set with proper label, pre-processed document set with proper label and the value of k. Now the test set, how to apply that k nearest neighbor. Suppose a document came, then we will just take based on this formula. Here it is whether belongs to same class. This intersection shows whether belongs to how many of them are common in same class in nearest neighbor, and then select the pj and then calculate the argmax. Actually argmax j is equal to calculated by using same technique, and decide whether that document will be the part of given cj class or not. Here pj estimates pj is equal to ci by sk, and this is equal to cj divided by d, and cj denotes the set of all documents in the class. So in the set of all documents in the class, how many are similar with sk divided by k to calculate the k nearest neighbor. This is a probabilistic calculation, just as used here earlier, like here. K is the k nearest neighbor, and like that. So either use the probabilistic maximum or use this decision factor to identify the class. Now some important points with k nearest neighbor classifier. The k nearest neighbor classifier determines the decision boundary locally. Means there is no global information required about document. For this is a simple example which use the one nearest neighbor based classifier. This is equivalent to a Voronoi diagram. Here represents the documents with same set, and these cross marked documents are related to different set. Each document's region are depicted with the help of This document's region are depicted with the help of Voronoi diagram. This also depicted with the help of Voronoi diagram. That's why it is different, and it is based upon the Voronoi diagram construction technique, and to calculate the distance between two documents and to maintain this boundary and maintain these differences, we use the document vector score for each document with Voronoi diagram based technique. But one nearest neighbor is not very robust. It is very prone to the noisy or noise related errors. For example, suppose this is a class. This is a properly defined class. Now if I use this is the noisy points. These are the noisy points. Now suppose we put one point here, then based on the nearest neighbor, number of nearest neighbor points, suppose these two are one nearest neighbor, suppose this is nearest to this noisy point, then we will get wrong classification. Suppose another point come which again so nearest distance with this noisy point, then again it will create wrong classification. But if we increase the number of classes, number of nearest neighbor, then we can reduce this situation. For example, in this case, if we use 5 or 6, then it may cover more information. Then we can put this into right class. So generally with k is called k greater than 1, it is more robust, and it assigns the documents to the majority of class of their k closest neighbors with ties broken randomly. More robust alternative to find the k most similar example and return the majority category of these k examples. The value of k is typically odd, like 3, 5, that I already discussed why we select odd numbers for k, just to avoid the ties condition. This is also called k nearest neighbor based classifiers, also called case based learning and memory based learning or lazy learning, because we fix everything in memory. Means after getting the document sets, we pre-process them, separate the documents in their classes, identify the k, and then put everything into memory, and then we for new documents we calculate the class for new documents by using the data preserved in the memory. This is also called lazy learning. Now this is a k nearest neighbor decision boundary. Boundaries are in principle arbitrary surface, but usually a polyhedra. This is sample classification example by using k nearest neighbor. Actually, KNN gives locally defined decision boundaries between classes. Far away points do not influence each classification, unlike classification decision, unlike in naive-Bayes or Rocchio classifiers, where farthest point can also create some influence on classification. Here it is not possible. Similarity matrices and complexity. Actually, in k nearest neighbor classifiers, we can use multiple types of similarity measures, like Euclidean distance, Hamming distance, cosine similarity. Nearest neighbor method depends upon the similarity or distance metric. Means selection of appropriate distance measure is also important in the quality of classification with k nearest neighbor algorithms. The simplest for most continuous m-dimensional instance space is the Euclidean distance, and the simplest for m-dimensional binary instance space is Hamming distance. Hamming distance generally performs better in case of binary classification. It is already proved. For text, cosine similarity and of TF-IDF weighted vectors is typically most effective. It is already discussed with Rokio classifiers. And TF-IDF weighted cosine similarities generally perform better in other text-related similarity measures and approaches also. Testing time is big O of BT, where B is the average number of training documents in which test document word appears. Typically, B is very less than total number of size of documents. A simple illustration of 3 near neighbor classifier with text vector space. Here, red documents represents the vector space of red documents, blue arrow represents the vector space of blue documents. Now the black arrow represents the vector space for labeled as black document. Now these are to identify the nearest neighbor, we just calculate the cosine similarity of black documents with nearest. We selected 3 angles as the smallest nearest angle for this black vector, and based on this we classify the document. We find that majority of the documents nearest to that black document is blue, so we will classify this black document in the blue documents category. Now 3 nearest neighbor versus Rokio. Nearest neighbor tends to handle the polymorphic category better than Rokio. For example, here red arrow represents the document. Red arrow or vector space represents the document of red level, and in the left side 2 arrow and right side 2 arrow. In between there are 2 arrow or vector space which represents the document with blue label. Now this is a document represented with related to black label and vector space. Now we find 3 nearest angle for this black vector space. We realize that number of blue documents, blue vector space or blue label documents are more than number of red documents. Only 1 red documents are present in 3 nearest neighbor for black documents, so we will classify black in the set of blue documents. But in Rokio classifiers we realize that black documents shown more similarity with the centroid. This may be centroid for all red documents, and this may be the centroid for all, and this may be the centroid for blue documents. This is for red and this is for blue. So it will show the less angle with the red centroid of the red document with respect to blue document, and it will be wrongly classified with red documents. This is not present here. Now some important discussion, like no feature selection is necessary with k nearest neighbor classifier. It scales well with large number of classes, means it doesn't require to train n classifiers for n classes. The classes can influence each other. A small change in one class can have a ripple effect. Scores can be hard to convert into probability. For example, if we consider the TF-IDF score or some other cosine vectors score, then it will be tough to convert the KNN score into probability. no training is necessary, but actually we will apply a very small training space, training session to pre-process the document, identify their classes and fix the value of k. May be expensive at text time. In most cases it is more accurate than naive Bayesian and Rokio classifier. This is the one of the merit of k nearest neighbor classifier. Bias variance trade-off. Variance is equal to variance is very near to capacity, and k nearest neighbor has high variance and low bias. This make this classifier more robust with respect to naive Bayesian and Rokio. While naive Bayesian classifier shows low variance and high bias, the decision surface has to be linear. Here it requires infinite memory because we have to store the entire Voronoi diagram. However, we can use the distributed system to store the part of Voronoi diagrams into memory for entire classification. Now, types of classifiers. Binary and multi-classifier problem. For a given training set of the form xi, yi, where xi is related to a real number Rn and is ith example and represents the ith example. Similarly, yi represents from 1 to k and is the ith class level. We aim at finding the learning model H such that Hxi is equal to yi for a new unseen example. Actually, in classification, there are two cases. First is the binary classification and second is multi-class classification. In binary classification, the class yi has just two labels, +1 or -1. But in multi-class classification, a class may be more than two labels. There are different approaches that applied with multi-class classification are: the first category of algorithms include decision tree, neural networks, k nearest neighbor, naive Bayes classifier, and support vector machine, which can support the multi-class classifier. The second category includes the approaches to converting multi-class classification problem into set of binary classification problem that are efficiently solved by using binary classifiers, for example support vector machine, etc. Other approach tries to pose a hierarchy on the output space, the available classes, and perform a series of tests to detect the class level of new pattern. Here, a approach of converting multi-class classification into set of several binary classification. For example, document D1 first classifies negative and positive. Then all negative sets are again classified into negative and positive. All negative sets, highly negative sets, are represented as one class, again classified as negative and positive. This is class 3. Again positive, class 2. Again this positive are divided as two classes. So this is the process of dividing a multi-class classification into binary classification system. This is a negative and positive actually represents the binary decision model. We can also use same technique but without binary decision model. We can create the hierarchy which may represent different classes which satisfy some particular thresholds or class related properties. Thanks.